Today, we're going to make our particle billboards face the camera. Let's go. Okay, so last week we started a brand new tutorial video series focused on making a particle system. If you're wondering why we're doing this or how to get started, go back and watch last week's video. That's where I explained the whole thing. I'll link it down in the description. Alright, so last week I showed you this particle stack mesh, and we're going to use each of these flat planes as our particles. Today we're going to make them face the camera so that no matter which direction we're looking at them, they're always pointing directly at us. That way, each of the planes can represent a volume of material and give the illusion of depth. Alright, so there are a couple of different methods of making our planes face the camera. I'm going to show two different methods today, one in Unity and the other I'm going to show in Unreal. But you should be able to use these interchangeably. I don't think there's much difference in performance between the two different methods. Mostly the differences revolve around how we identify each of the four vertices of the planes. In Unity, we're going to use position, and in Unreal, we're going to use the UV coordinates. Alright, so let's get started with the Unity version of our camera-facing billboard shader, and then we'll switch over to Unreal and I'll show you how to do something similar there. So the first thing that we need to do is create a new subgraph. So I'm going to come down here and right-click and pick Create Shader Graph Subgraph. And I'm just going to call this Billboard. And this is going to be our subgraph that actually does the transformation. So we're rotating our planes into to face the camera. So the first thing that we need to do is bring in the position of our vertices. And we're going to set this to object space position. And then the next thing that we need to do is multiply our position by our scale. So I'm going to add a multiply node here. Actually, you know what? Before we continue, there are two parameters that we need to create in our blackboard. So let's bring up our blackboard here. And I'm going to add a position parameter. And that's a vector 3, and I'm also going to add a scale parameter, and that's just a float. All right, we're going to use our position parameter in a minute, but let's take our scale parameter here, and we're going to bring in our object node that has a bunch of different parameters for our mesh object. In this case, we want the scale of our mesh. So if we're scaling our mesh up and down, we can use that scale value in what's happening in the shader here. All right, so we're going to multiply the object's scale by the scale parameter that we input. This scale parameter here is going to allow us to change the size of our particles. We're going to make them get bigger over their lifetime or get smaller over their lifetime, that sort of thing. And so we'll use this scale parameter in order to do that. Alright, so we multiply our scale by our object scale, and then we multiply these things by our position. Now, in some cases, we're going to want to pass in something other than just our raw position value. And so that's what I'm going to use this position parameter for. And what I'm going to do is make it so that if this position parameter is empty, we're going to use this raw position parameter. But if this position parameter is connected in our subgraph, then we'll use whatever is connected instead. And the way that we do that is we're going to create a branch on input connection node. And so this node will allow us to branch based on if something is connected to our input port. So if something is connected to our input port, we want to use that. So whatever is connected, we're going to use that. But if it's not connected, we're going to use our position. And then we're going to use the result coming out. All right, so we've got our object position, which is our default value if nothing is connected. And if something is connected, then we're going to use this connected value instead. And we need to define what our input is, and so we're going to drag this over and connect it. But we can't connect it yet. And why is that? Well, on our position value here, we need to select position, open up our graph inspector, and we need to check this box called Use Custom Binding. And now it's going to give us the option to add in a label. And for the label, I'm just going to type object position. So by default, that's going to give us the object position. All right, so now that we have that Use Custom Binding box checked, we can drag this parameter over and connect it to our input. So we're going to branch based on whether or not something is connected to position. If something is connected, we're going to use that. But if something's not connected, we're going to use this raw object space position instead. All right, so that gives us a little bit of flexibility in our billboard node. We can leave something we can connect something to position, or if not, we can just default it to using the object space position. All right, the next thing that we need to do is transform our position. And so we're using this position here as the camera position or the view position, and we need to transform it into world space. And so in order to do that, I'm going to add a transformation matrix, and I'm going to pick inverse view because we want to go from view position into world position. And so we're going to multiply by this matrix. But one problem that we have here is that this value is a vector 3 and it needs a vector 4. And so in order to create a vector 4, I just need to append a 0 to the end of it. So I'm going to add a split node here. We're going to take the X, Y, and Z components and pass them into a vector 4. So I'll take X and Y and Z, and then our fourth component, we're just going to leave that as 0. So now we can connect this vector 4 and multiply it by our inverse view matrix to get the transformation that we're looking for. And now that we're in world space, we're going to add the object position. So there's the position of our billboard planes object that we're adding in. And then finally, because Unity needs us to pass the object space position into the master stack, we're going to add a transform node here, and we're going to transform from our absolute world position into object position. So we give Unity what the master stack wants, and we're going to leave the type set to position. All right, so this is our billboard node, and our output, we need to open up our graph inspector here and set up our output. We're just going to call it out, and we're going to, actually, to more accurately represent what it is, let's call it position. And this is going to be a vector 3. All right, so we'll take our transform node here and connect it to our output. All right, so this shader will transform our planes and make them always face the camera. So let's test it out. I'm just going to save it, and then we'll come here to our particle system shader. This is the one that we created last week. And right now, all it's doing is passing the vertex color into the base color of the fragment shader. And that's what we're getting here. So you can see our vertex colors go from white to black. And if we take this new billboard subgraph that we created, you can see here that by default, it's passing in the object position and our scale is 0. Ooh, that's bad. We should fix that. We need to set the default value for our scale to 1, because if it's 0, we're not going to see our planes at all. Okay, so now we can connect this billboard subgraph to the vertex stage position node. And if we save this and take a look at our result, where did our object go? We've done something wrong here. Let's go back and take a look at our particle system again. I see. So our scale value is set to 0. We set the default to 0, but since we'd already created this instance of the subgraph, our value stayed at 0. So now it's a scale of 1. And you can see we get the nice colors here in the preview. Let's save this. And there we go. Bingo. So now we've got all of those particle planes facing the camera. So no matter which way we rotate this, we're always going to get our billboards looking straight back at us. All right, now I want to do one more thing here, and that is I want to make this billboard subgraph a little bit more flexible. Right now, we're depending on the billboards that we created always facing the proper direction. We don't have an option, so if I create a plane that's starts out facing a different direction, I don't have a way in this particular billboard shader of fixing it. It requires the planes to always be facing -z in order to work correctly. So what I'm going to show you next is a little bit of a bonus. This isn't strictly required for the particle system that we're working on, but it will allow you to make a billboard subgraph that's a little bit more flexible so that you can create your initial billboard planes facing any direction you want, basically, and you'll be able to select that direction. So what I'm going to do here is move these nodes over, and right here in this space, we're going to add a drop down that will allow us to select the initial facing direction of our billboards and compensate for that facing direction here in the shader. So I'm going to open the billboard, the blackboard again, and we're going to add a drop down parameter. And for our drop down parameter, we're going to come over here to the graph inspector, and we're going to call this the forward axis. So now you can see I have the ability to define a bunch of different options here for our drop down. So these are going to be like what's available in the drop down menu. So for these options, I'm going to add +x and -x. We'll add +y, -y. These are all of the potential directions that our initial plane mesh could be facing. And then I'm going to add +z and -z. And so these are the forward directions that the planes are facing. And I happen to know that the planes I created for the particle system are facing -z. And so we're going to set -z as the default. All right, so now we have a drop-down node that I can add in here. And this will branch our shader based on all of these different selections. So if the user selects +x from the drop-down, they'll get whatever's passed into this pin, etc. All right, so let's make ourselves some space here. The -z that we created is this last one here. So I'm going to wire these results into that and then pass the results out. But now we need to create all of the rest of the inputs here. And so what we're going to do is take the position input that we're getting and modify it a little bit so that it fits the proper criteria. So I'm going to drag out from here, and we'll add another multiply node. And for +x facing planes, we need to multiply by 1, 1, -1. And then we need to swizzle our components around. So I'm going to make this y, z, x. Right, so if our plane is facing +x, we multiply the z component by -1, or we negate it. And then we swizzle our components so we have y, z, x. All right, for -x, we just negate the whole thing. And then again, we're going to swizzle YZX. So you can see for each of these different plane facing options, we're going to have, different modifiers that we need to add so that we can get that plane facing the camera. So for positive Y, we're going to negate it and then swizzle to XZY. For negative Y, we're going to multiply by 1, -1, and -1. And then just the same here, we're going to swizzle XZY. Let's connect these up. And then for our last one, we just need to multiply by -1, 1, and 1. All right, so that's going to be our positive Z. All right, so you can see for each of these different possibilities for the direction that our initial plane is facing, we have these different modifiers that we added so that we can compensate for that facing direction and turn it so it's facing the camera. Okay, so if we save this and we switch back to our particle system shader, now you can see that I have this forward axis drop down, and I can select the direction that our plane is facing initially, and that will allow the billboard node to correctly handle that particular case. In my case, I know that our planes are all facing -Z, but if I were to make a different mesh and they were facing a different initial direction, I could use this drop down to use basically any initial direction for my planes. So that makes my billboard node just a little bit more flexible and gives me the freedom to use this in more cases. All right, so we've made our particle planes always face the camera. Like no matter which direction we rotate around, these planes are always facing the camera. And that allows them to simulate these volumetric effects that we're getting here. So you can see here, these planes are always facing, and it makes it look like there's some depth there. All right, so that's the video that I'm going to show you for today. In just a second, we'll switch over to Unreal. But first, next week, what we're going to do is we're going to take each of these planes and assign them a random value, a random color, actually. We're going to use a hash function. I'm going to show you how to create a hash function that will give a random color to each of our planes. And that color is basically a vector 3 value with 3 random values. And we can use those values for each of the particles to create unique behaviors for movement, rotation, scale, and other things like that. So that's what we're going to get into next week. All right, let's switch over to Unreal, and I'll show you the method for making our particles face the camera there, where we use the UV coordinates instead of the position. All right, here we are in Unreal, and you can see just like we did in Unity, we have our stack of particle billboards, and we're going to create a material function today that allows us to make these billboards face the camera. So the first thing that I'm going to do is open up my content drawer here. I'm going to right click in here, and under material, I'm going to pick material function. And we're going to call this material function billboards, and I'll double click to open it up. All right, like I said before, in Unity, I showed you how to use the position method for making the particles face the camera. And in Unreal, we're going to use the UV coordinates to identify the vertices and make things face the camera instead. So the first thing that I need to do is bring in our texture coordinate node. This is going to be a default, but for the material function, I need an input node here. There's our function input, and we're going to come over here and give it a input vector 2, because UV coordinates are 2. And then I'll wire my texture coordinates into the preview there so that texture coordinates are the default. What this allows me to do is when I add this material function to my graph, if I leave this input disconnected, it'll use these texture coordinates as the default. All right, the next thing that I need to do is, in Unreal, UV coordinates are top to bottom, meaning at the top left-hand corner, their value is 0. But I actually need them to be bottom to top. And so what I'm going to do is I'm going to create a component mask here. And we're going to mask out just the red channel. We're going to leave the red channel alone. We're just going to pass it through. But for the green channel, we need to invert it. So I'm going to add another component mask. And this time I'm going to select green here. And now I need an append node so that I can connect them back together. So I'm going to append the red with the green. But the green, we need to add a 1-. And this is going to swap that green channel around so that my zero value is at the bottom instead of the top. All right, so I just rearranged my UV coordinates, and this will allow us to use the UVs to identify the positions of the vertices. We're basically saying the UV coordinates are the positions of the vertices in camera space. The other thing that I need to do is subtract 0.5. And the reason that I'm doing that is right now my range is from 0 to 1 and 0 to 1. And I actually want all of the vertices of my plane to be equidistant from the center. And so I'm going to subtract 0.5 here to center the value of those UV coordinates right around the center of the plane. All right, the next thing that I need to do is normalize, because what I've got here is now a vector where each of the UV coordinates is a distance from the center. And I want that distance for each of the coordinates to be a value of 1. And so normally I would just add a normalize here. But if my value is right in the center and I try to normalize it, normalizing a value of 0, 0 is going to give me a divide by 0, which will result in a bad value. That's like not a number. And so I need to do the same thing as a normalize, but in this case I need to do something called a safe normalize, which prevents those divide by 0 errors. So the way that I'm going to do that is add a dot product node. I'm going to dot product the value by itself, and then add a square root. And this is basically taking the length of the vector. But then, in order to do my safe normalize, I need to add a max node here, and basically give it a really small number here, 0.00000001. And this will prevent the divide by 0 condition. So in order to normalize now, I've taken the length, and then I need to get the original value and divide that by the length. So these nodes together here do a normalize, but it's a safe normalize because it prevents it from ever dividing by 0. All right, so now all of the vectors that go from the corners, the vertices, in toward the center, because I've normalized them, now their unit length, they're a value of 1. The next thing that I need to do is find the distance between the object position and the position of each of the vertices. So I'm going to take my world position node here and find the distance between that and the pivot point of my object, or my object position. So this is going to tell me how far away each of the vertices is from the center of the object. And we're going to multiply our normalized vector by that. And now we also need to bring in a scale parameter. So I'm going to add another input here. Here's my function input. And I need this one to just be a scalar. So I'm going to pick function input scalar. And we'll give it a default value of 1. So by default, we're going to make sure that our particles have a scale of 1. And we'll multiply by that. All right, so now that we're correctly handling our scale, we need to do some transformation. So I'm going to add an append node here. Just like we did in Unity, our transformation needs to... Whoops, that's an append many. I just need an append. Our transformation needs to have the right data type. So I'm just going to append a 0 here, so that I can tack on one more component. And now we're going to add a transform node. So what we've calculated up to this point represents the position of the vertices in camera space. And when we do vertex manipulations in Unreal, they need to be in world space. So we're going to pick camera space here and world space there. We're transforming from camera space, which is what we've calculated here, to world space, which is what Unity needs, or which is what Unreal needs to transform the vertices. And then once we're in world space, there are two more things that we need. We need to add on the position of our object. And then we need to subtract out the absolute world position. And then our output here is called result. And instead of result, I'm going to call it position. All right, so we're passing in our UV coordinates and a scale value. Oh, we need to name this one as well. I'm going to call this scale. And the other thing that I need to do for our inputs is give them a sort priority. So this one's going to be 0, and our scale is going to be 1. And I need to make sure that I pick this use preview value as default box here. All right, so that is our material function that's going to transform our billboard stack and make sure that all our planes are facing the camera. All right, pretty cool. So let's save this, and we'll switch over to our vertex color material here, which is what we created last week. And you can see it shows the vertex color of our planes. And now we'll open up our content drawer and add in our billboard material function. So you can see I have my in and my scale. Actually, you know what? For in, I think I want to name this one UVs. So let's go back here. And instead of in, we're just going to call this UVs. And we'll save it again. Switch back. There we go. So now we have our billboard node and it's called UVs. And now I can just take this and plug it into our world position offset. And now what do we have? We have billboards that always face the camera. You can see there's a little bit of Z fighting because there's a whole stack of billboards here, and they're all kind of trying to face the camera in the same position. But we can see that our material function here is working correctly, and we've got our billboards nicely facing the camera now. All right, like I said before, the thing that we're going to do next week is I'm going to show you how to create a function that's called a hash function that will allow us to take these vertex colors that we have coming in and convert this. Right now we have vertex colors that are just grayscale, and our hash function is going to give us a color, a random color for each of these grayscale values, and then we can use that red, green, and blue random number to assign random values to things like the position, rotation, and scale of our particles. I know that we're getting started a little bit slow here, and that this doesn't really look much like particles yet, but what we're doing is building the foundation now for something that over the next couple of weeks is going to develop into a particle system that we can use to achieve effects like this waterfall, like this chimney smoke here, like this fountain, and like this drifting mist. So I hope that you'll have a little bit of patience as we kind of move along here. So far, I've showed you how to create our particle meshes and also how to make the particle mesh face the camera using this billboard node. Right, so next week, come back to learn how to create a hash function that will give us a random color value for each of our particle billboards. All right, have a great week, everybody, and we'll see you next time.